Hello everyone, welcome to our EEE 416 project presentation. The title of our project is Internet of Things based Bangla calendar clock. Our presentation outline gets divided into 6 parts: abstract, introduction, design, implementation, analysis and evaluation, and finally references. In our project, we designed a digital calendar clock which displays Bangla time, Bangla day period, and also Bangla weekday. We included calendar date both in Gregorian and Bangla to make it compatible with our normal schedule. Our clock can synchronize the displayed time from internet and ensures accuracy. If we ask what's the date today, everyone will answer 31st August. But what if we ask the same question just in terms of Bangla calendar? There is high probability no one can answer this. The reason behind it is we almost lost the track of Bangla calendar. Our project of Bangla calendar clock helps us to keep in touch with our culture and to keep track important days and festivities. There is one more issue. In rural areas, people need to keep track of Bangla months for agricultural purpose such as crop cutting, harvesting and sowing. Also, our implementation makes such a clock that is accessible to those portion of people who have just Bangla literacy in rural area. In our design, we used Arduino Nano. We included RTC module and ESP01 Wi-Fi module as peripheral components. We used ESP Wi-Fi module to connect Arduino to internet. We have created API request to fetch date and time data. We used RTC module to store English data and EEPROM to store Bangla data and thus keep track of the date and time in case of power loss. We merged two 32 by 16 LED matrix to display our data. In our Arduino code, we implemented serial and SPI communication. We have done string parsing and manipulated matrix in order to show our final output in LED matrix board.
Here is the circuit diagram of our project. We can see the Arduino Nano connected to the RTC module, the ESP01 module and the P10 LED matrix module. There is a 9-volt power input and a ground pin here as well. Also, there are some debugging header pins and a button and an LED also for debugging purposes. Unfortunately, the RTC module and P10 LED matrix modules were not available in Proteus. Therefore, the initial prototyping of the circuit was done in breadboard before implementing the final setup in a PCB. Our final PCB layout and 3D rendered version is shown here. We are using a double-sided PCB and it is made as compact as possible while keeping all the header pins of the modules. Also, there are connection swaps for debugging purposes, and also there is a potentiometer for controlling the LED matrix brightness. Here we can see the normal operation of our clock. The time is currently 7 p.m. and 58 minutes, and we can see the date scrolling past 30 August 2022. We just witnessed the transition of our time from 7:58 to 7:59, and we can see the PM showing as Aparanno, and then the weekday Mongolbar, and then the Bangla date, which is 15 Bhadro 1429. Now we will demonstrate our clock module turning on without a Wi-Fi signal. First of all, let's turn off the Wi-Fi and turn on the clock and turn it on again. So right now the ESP module is trying to connect with the Wi-Fi. However, there is no Wi-Fi signal. So the ESP module will continuously try to connect with the Wi-Fi. There is a timeout of 1.5 minutes. So if the Wi-Fi module cannot connect with the Wi-Fi within 1.5 minutes, then the, the Arduino module will fetch the previously loaded RTC English date, also the EEPROM data stored in Bangla, to restart the clock with the previous values. And here we can see that the clock has turned on again. Now we will see a synchronization action of our clock. The clock here is set to synchronize with the internet at 9 past 3. So as soon as the clock hits 9 past 3, the DMD module will switch off and the ESP module will turn on, and the clock will attempt to synchronize with the internet. Right now the ESP module is sending API requests to the server and fetching the real time and date information. This takes quite some time, so the clip here is sped up. Once the fetching the data is complete, the LED matrix will once again turn on. And here we can see the module has turned on again. In the photo gallery, we can see the wall-mounted version of our project. The wall clock is showing both Purbano and Operano outputs here. Also on the right there is the ThinkSpeak website, which is being used to create all the live time and date API requests. And now the next team member will discuss the analysis and evaluation of our project.
Hello, I am Sadat Hamid Azad, roll number 64, and now I will discuss the analysis and evaluation of our project. First, we will turn to the novel aspects that are implemented. There are previous designs of Bengali clocks that have only incorporated the time in Bengali digits, mainly into 8x8 LED matrix or segmented displays were used, which are usually the first choice for such projects as they are commonly available in the market. In our project, however, we had to keep in mind that our clock would have to be mountable and the text discernible from a distance. So we had to go for a larger and more efficient displays and hence LED P10 boards, which are 16x32 LED boards. These were of the obvious choice. We had used two of these boards. Apart from this, the novelty of our work lies in the fact that we have added AM, PM, day of the week, English and Bengali dates in Bangla letters, which is not very common as per our knowledge. This kind of clock is not very commercially available in the market. We had to design our clock maintaining these prospects while also keeping an eye on the overall cost. Next, we turn to the bill of materials. We can see that each LED P10 matrix costs 700 taka and some transport. There were some delivery costs which are excluded in this table. We also used Arduino Nano and some other modules, the price of which is listed in this table, and the overall price is around 3,150 taka plus additional costs. Next, we will turn to the practical considerations of the design. If we want to look at the public health and safety issues, the clock is enclosed safely in a metal casing that is welded in order to ensure maximum protection, and a securing mounting mechanism is in place. So the clock hangs from the wall securely without the risk of falling. Our clock is also not that much heavy, so it is actually a very safe device. For environmental issues, no pollutant was reported in our clock. The most important impact of our project is its cultural and societal needs, because it is a technology that has the potential to represent and revive our mother language. It will hopefully help us to keep track of Bangla month and dates that we almost forget to use nowadays. We hardly can say which month or day today is according to the Bangla calendar. Now we can just look at the wall and stay updated with this neglected aspect of our tradition. We also want to address some issues that we may have faced. Fortunately, there were no societal issues, there were no health or safety issues because our pack is safely in a metal box, and we did not face any legal issues related to patent infringement or copyright violations. For cultural issues, our project promotes the awareness about the Bengali culture and heritage and has no issues regarding misrepresentation or appropriation of culture. For the last part in this section, we will want to evaluate the sustainability of this project. We developed the model with sustainability in mind, so we wanted the clock to be reliable and strong. The metal casing that we used is very sturdy and provides a robust housing for the electrical parts inside. The module runs from the socket, therefore there is no need for constantly charging batteries. From a societal point of view, the design is kept simple and compact using dark color and not too flashy. Similar clocks are very common in our local mosques and offices, so it can be used in our societal setting with ease. From the point of view of environmental context, since we do not have to use large external batteries and have opted for long-lasting materials, detrimental effects to environment are kept minimal.
Hello, this is Abdullah Zubair, role 58, and I'm going to focus on the reflection on individual and teamwork section of this presentation. If we look at the individual contribution of each member, we can see that Saleh Ahmed established the Wi-Fi link between Arduino and the internet using the ESP module, generating and maintaining the API request for the time and date in the ThinkSpeak website, and he also led the PCB design section. Tiyasha Mondal established communication between the RTC module and the LED matrix, ensured that there is a conflict-free communication between the two modules, and she also immensely helped in the hardware assembly. For me, I have done the string parsing to convert the RTC and ESP module output to date and time integers for using in the display portion of the code, and I have implemented the EEPROM for storing the Bengali date. And Sadat generated the custom Bangla fonts in the LED display, displaying static and scrolling text in the runtime and incorporating display code with the rest. And frame design idea and management was also done by him. Though all of us divided our work primarily, we help one another in parts time to time to quicken the work and to keep the overall idea of our project solid. Saleh has always been the most focused member of the team, always pushing everyone to finish their tasks after doing the heavy lifting himself. Tiyasha has been immensely helpful in terms of debugging, searching for the appropriate parts, and making sure that the hardware components are proper. I have always been about efficiency and making the best use of everyone's time, always finding quicker and faster ways to solve the problem. And Sadat has been the most approachable person of the group. Whenever there was an issue, we could all just reach out to him and he would help us find a solution. All in all, it has been an amazing experience working together as a productive team. The team members are from different cultural and religious backgrounds. Our female team member, Tiyasha Mondal, is based in Dhaka, while Sadat Ahmed had his early education in suburban areas. The other members, Abdullah Jubair, me, and Saleh Ahmed Khan, also spent their whole childhood in Dhaka. In our group, Tiyasha is an extrovert, while Sadat, Saleh, and I are introverts. It has been quite a work experience for all of us. We have had our disagreements during the project work. Through collaboration and friendly interaction, we came to understand and settle our differences and find a common ground for successful teamwork. Here we can see a few pictures of us, and on the left side we can see that the clock is functioning, and this was taken yesterday. And there's this other picture on the right, but we are still working on the clock. Here we can see the logbook of the project, and we can see that all the individual tasks that we planned to get done were done in the appropriate deadline, and by 20th August we were done with the final framing of the clock, and our first prototype was completely ready.